You saw alien ships.
Yeah.
Dive into the enigmatic world where science meets the unexplained.
There's been an awful lot of misinformation. If you don't know what's going on, you might like to find out.
Bob Lazar, a name synonymous with Area 51 and alien technology, catapulted the mysterious element 115 into public consciousness.
Ran on element 115, and there's no evidence that we have this even occurring naturally anywhere on Earth.
But was he a herald of hidden truths or a weaver of fantastic tales? Let's unravel the story. Bob Lazar, the man who told the world. In the late 1980s, a figure emerged who would become one of the most controversial and intriguing in the realm of ufology and extraterrestrial technology. Bob Lazar claimed to have worked on reverse engineering alien spacecraft at a secret site near Area 51, known as S4. His assertions, particularly about the existence and use of element 115, Moscovium, as a power source for these crafts, have sparked debates, skepticism, and fascination for decades. Bob Lazar was not a household name until November 1989, when he appeared in a televised interview with investigative reporter George Knapp on Las Vegas local news. Concealing his identity initially, Lazar detailed his alleged work with the United States government on extraterrestrial technology. His background was as mysterious as his claims. Lazar professed to hold degrees from the Massachusetts Institute of Technology, MIT, and the California Institute of Technology, Caltech, although there are no records to support these claims. According to Lazar, his role at S4 involved studying an alien spacecraft to understand its propulsion system. This system, he claimed, was powered by an antimatter reactor using element 115, which at the time had not been synthesized or officially recognized by the scientific community. Lazar described the element as the fuel source that allowed for the creation of a gravitational field, enabling the craft to fly and to travel vast distances through space at incredible speeds. Lazar's claims brought the then theoretical element 115, later named Moscovium in 2016, into the limelight. Scientists had predicted the existence of element 115, but it was not synthesized until 2003 by a team of Russian and American scientists. While Moscovium's properties did not exactly match Lazar's descriptions, most notably, its instability and short half-life, the mere existence of the element added a layer of intrigue to his assertions. Critics of Lazar point to the lack of verifiable evidence of his education and employment at S4, alongside the technical implausibility of his claims. The absence of any publicly known stable isotopes of element 115 that could function as described in Lazar's alien propulsion system casts doubt on the feasibility of his story. Moreover, Lazar's descriptions of the alien craft and its operations have been critiqued for lacking consistency with known physical laws. Despite the skepticism, Lazar's story has had a significant impact on popular culture and the UFO community. He is considered by some as a whistleblower who exposed one of the government's most closely guarded secrets. His interviews have been viewed millions of times on the internet, and he has been featured in documentaries, books, and conferences discussing alien technology and government secrecy. Today, Bob Lazar remains a polarizing figure. To some, he is a courageous figure who brought the world's attention to the possibilities of advanced extraterrestrial technologies and the existence of UFOs. To others, he is a fabricator who capitalized on the public's appetite for the unknown. Regardless of one's stance, Lazar's narrative has undeniably contributed to the discourse on extraterrestrial life and technology, pushing the boundaries of what we believe is possible and challenging us to question the known confines of science and technology. Element 115, unpentium to Moscovium. Element 115, known as Moscovium, embarked on a remarkable journey from theoretical speculation to a defined seat at the periodic table's Grand Assembly. This journey not only underscored the meticulous pursuit within the realm of scientific inquiry, but also highlighted the profound implications that such discoveries hold for our understanding of the universe and the potential technologies of the future. The story of Moscovium begins in the complex world of theoretical chemistry and physics. Prior to its discovery, scientists had long predicted the existence of element 115, based on the periodic law and the structure of the periodic table. Theoretical models suggested that it belonged to the group of elements known as the super-heavy elements, lying in the island of stability. a term used to describe a region in the periodic table where superheavy elements might exhibit relatively longer half-lives due to specific nuclear configurations. The race to synthesize element 115 was not just a pursuit of scientific curiosity, but also a testament to human ingenuity and collaboration. It was in the early 2000s that researchers at the Joint Institute for Nuclear Research in Dubna, Russia, in collaboration with the Lawrence Livermore National Laboratory in the United States, announced the synthesis of ununpentium, the temporary IUPAC name for element 115, moscovium. This synthesis was achieved through a complex process involving the bombardment of atoms of americium with ions of calcium, creating atoms of element 115 that existed for mere fractions of a second before decaying into lighter elements. Moscovium's properties are as intriguing as its path to discovery. With an atomic number of 115, it is characterized by its extreme instability, existing only in laboratory conditions before rapidly decaying. The most stable isotope of moscovium, Mach 290, has a half-life of about 0.65 seconds, presenting significant challenges for scientists attempting to study its properties in detail. Despite these challenges, the synthesis of moscovium and its isotopes provides critical insights into the behavior of superheavy elements and the forces that govern atomic nuclei. The discovery of moscovium has profound implications for both theoretical and applied science. Theoretically, it provides invaluable evidence supporting the models of nuclear structure and the predicted island of stability. This enhances our understanding of atomic behavior at the extremes of matter, offering clues about the forces that hold nuclei together and how the periodic table extends beyond the elements known today. From a technological perspective, while the immediate applications of moscovium are limited due to its instability, the processes developed for its synthesis and the study of its properties have wide-ranging implications. These methodologies push the boundaries of particle accelerator technology, detection methods, and the chemistry of superheavy elements. They lay the groundwork for future discoveries in the realm of superheavy elements, which could one day lead to materials with novel properties and applications in energy, materials, science, and beyond. The official recognition and naming of moscovium in 2016 by the International Union of Pure and Applied Chemistry, IUPAC, was a milestone in the field of chemistry. It represented not just the addition of a new element to the periodic table, but the culmination of years of collaborative research that spanned continents. The name Moscovium, honoring the Moscow region and its contributions to the field of science, is a testament to the global nature of scientific discovery. In the context of Bob Lazar's claims about the use of element 115 in alien technology, the discovery of moscovium offers a fascinating footnote. While the scientific community has not found evidence to support Lazar's specific assertions regarding the element's properties or applications in extraterrestrial propulsion systems, the very existence of moscovium captivates the imagination. It serves as a reminder of the vast unknowns in science, where today's theoretical elements become tomorrow's subjects of study and, perhaps one day, the foundation of new technologies. The science of UFOs, separating fact from fiction. The discourse surrounding unidentified flying objects, UFOs, occupies a nebulous space between skepticism and belief, where the pursuit of empirical evidence meets the allure of the unknown. The scientific community, traditionally rooted in empirical evidence and reproducible findings, approaches the UFO phenomenon with caution, emphasizing the need for verifiable data. This chapter explores the scientific stance on UFOs, the impact of declassified information and government admissions, and how these developments align or conflict with Bob Lazar's claims. The mainstream scientific community maintains a stance of skepticism towards UFO sightings and alien visitation claims, primarily due to the lack of incontrovertible physical evidence. Scientists argue that extraordinary claims require extraordinary evidence, a standard that many UFO reports fail to meet. This skepticism is further fueled by the high likelihood of alternative explanations for sightings, such as atmospheric phenomena, optical illusions, or man-made objects, which can often be mistaken for extraterrestrial spacecraft. In recent years, the veil of secrecy surrounding military encounters with unexplained aerial phenomena has begun to lift. Governments worldwide, most notably the United States, have started to acknowledge the existence of unidentified aerial phenomena, UAPs, that defy conventional explanation. The declassification of military footage and pilot testimonies concerning encounters with objects exhibiting extraordinary flight characteristics has injected new vigor into the discussion. These admissions do not confirm the extraterrestrial origin of these objects, but acknowledge that there are observations that currently lack a comprehensive explanation. This distinction is crucial. The acknowledgement of UAPs is not an endorsement of alien visitation, but an admission of unexplained phenomena that warrant scientific investigation. Bob Lazar's narrative about reverse engineering alien spacecraft at Area 51 and the use of element 115 as a propulsion mechanism finds both indirect support and significant contention within the context of recent disclosures. On one hand, the government's acknowledgement of UAPs provides a backdrop that makes Lazar's assertions appear less far-fetched than they might have seemed decades ago. It suggests that the military and government agencies take the possibility of advanced, unidentified aerial technologies seriously, which could be seen as aligning with Lazar's claims of secret projects. On the other hand, the scientific scrutiny applied to Lazar's specific allegations about alien technology in element 115 reveals significant gaps. There is no publicly available evidence to support the existence of an anti-gravity propulsion system, or that Moscovium, element 115, has been used as Lazar described. The properties of Moscovium, as scientifically understood, do not match Lazar's description, particularly regarding its stability and potential as a fuel source for interstellar travel. The evolving narrative around UFOs and UAPs underscores the importance of scientific methodology in investigating the unknown. Scientists advocate for systematic observation, data collection, and analysis as the means to understand UAPs. This approach seeks to separate fact from fiction, identifying natural or human-made causes for sightings and isolating truly unexplained phenomena for further study. Recent initiatives, such as the Pentagon's UAP Task Force, represent a concerted effort to bring scientific rigor to the investigation of unidentified aerial phenomena. By compiling and analyzing data from credible witnesses and sophisticated tracking equipment, these efforts aim to provide a clearer picture of what is being observed and to identify potential threats to aviation safety and national security. The scientific investigation of UFOs and UAPs does not validate nor refute Bob Lazar's claims directly. Instead, it highlights the complexity of exploring phenomena that exist at the fringes of current scientific understanding. Lazar's narrative, fascinating as it may be, remains unsubstantiated by the kind of evidence that scientific inquiry demands. However, the recent shift towards more openness and the application of scientific principles to the study of UAPs is a positive development. It creates a framework within which claims like Lazar's can be evaluated and encourages a more informed and nuanced public discourse on the subject. The physics of anti-gravity. Is interstellar travel possible? The concept of anti-gravity and interstellar travel captivates the imagination, offering visions of a future where humanity transcends the confines of Earth to explore the cosmos. Theoretical physics provides a framework for understanding how such feats might be possible, delving into concepts that challenge our conventional notions of space, time, and energy. This chapter explores the theoretical underpinnings of anti-gravity and warp drive technologies, and how element 115, as proposed by Bob Lazar, could theoretically play a role in such advancements. Anti-gravity, or the counteraction of gravity's force without the use of mechanical means, remains a speculative area within physics. Conventional understanding dictates that gravity is a curvature of spacetime around masses, as described by Einstein's general theory of relativity. Overcoming or manipulating this force implies a need to interact with the fundamental fabric of the universe in ways not currently achievable with known technologies or physics. One of the most tantalizing concepts for achieving faster-than-light travel is the warp drive, a theoretical proposition that involves bending or warping spacetime itself. The Alcubierre drive, a model proposed by physicist Miguel Alcubierre, suggests that by expanding spacetime behind a spacecraft and contracting it in front, a bubble could be created that moves faster than light, with the spacecraft inside this bubble not violating the speed of light within its local frame of reference. This concept sidesteps the limitations imposed by the speed of light by manipulating the space around the vessel, rather than accelerating the vessel itself. Bob Lazar's claims introduce element 115, Moscovium, as a key component in the supposed alien propulsion system, suggesting it could generate a gravitational field when bombarded with protons. In theoretical physics, the concept of exotic matter with negative energy density plays a crucial role in proposals for warp drives and anti-gravity technologies. Exotic matter could theoretically create the conditions necessary for space-time manipulation, as required for the Alcubierre drive. However, moscovium, as we currently understand it, does not possess these properties. It is highly unstable and decays rapidly, with no known capability to generate or manipulate gravitational fields in the manner described by Lazar. The leap from theoretical models to practical technologies in the realm of anti-gravity and interstellar travel is vast. The energy requirements for creating a warp bubble, for instance, are astronomical, initially estimated to be equivalent to the mass energy of a planet like Jupiter. Recent theoretical advancements suggest these requirements could be significantly lower, but the creation and stabilization of a warp bubble remain purely hypothetical, with no experimental evidence to support the possibility as of yet. Moreover, the manipulation of space-time as proposed requires forms of matter and energy that are speculative at best. While the search for dark matter and investigations into the quantum vacuum might one day uncover phenomena that align with these requirements, the current state of knowledge does not provide a basis for anti-gravity or warp drive technologies. The exploration of anti-gravity and warp drive technologies underscores the infancy of our understanding when it comes to the fundamental forces of the universe. While the theoretical groundwork offers intriguing possibilities, the leap to practical application and the role of substances like element 115 in such technologies remain speculative. The journey toward interstellar travel is not just a technological challenge, but a profound inquiry into the laws of physics and the universe. Testimonies and skepticism, the Lazar effect. The narrative woven by Bob Lazar has polarized audiences and experts alike, sparking a phenomenon that can be termed the Lazar effect. This chapter delves into the array of public and scientific reactions to Lazar's claims, examining the spectrum of support and skepticism that has surrounded his story over the years. Lazar's revelations about Area 51 and alien technology captured the public imagination, igniting a fascination with UFOs and government secrecy that persists to this day. His detailed accounts of working on extraterrestrial spacecraft and the existence of element 115 moscovium, before it was officially recognized, granted him a cult hero status within certain segments of the UFO community. For many, Lazar's narrative provided a tangible link to the long-suspected but elusive government knowledge of alien life forms and their technology. Supporters of Lazar cite his early mention of Area 51 and element 115 as evidence of his credibility, arguing that his detailed descriptions of these and other specifics could not have been fabricated or guessed. They view Lazar as a whistleblower who risked his livelihood and safety to bring crucial information to the public eye. Conversely, the scientific community has largely regarded Lazar's claims with skepticism. Critics point out the lack of verifiable evidence supporting his educational and professional background, noting discrepancies in his recounting of events and the absence of any corroborative testimony from individuals with verifiable connections to his alleged work at Area 51. Furthermore, Lazar's descriptions of the alien propulsion system and the capabilities of element 115 clash with established scientific knowledge and principles. The instability of moscovium and its unsuitability for the applications Lazar described have been highlighted as significant inconsistencies in his story. The manner in which Lazar's story was disseminated, initially through televised interviews and later via internet platforms, played a crucial role in shaping public perception. The sensational nature of his claims, coupled with the era's growing mistrust in government secrecy, provided fertile ground for his story to spread. While some media outlets approached Lazar's narrative with a degree of skepticism, others presented his claims without substantial critical analysis, further muddying the waters of public opinion. The Lazar effect can also be understood through the lens of confirmation bias, where individuals are more likely to believe information that confirms their pre-existing beliefs or hypotheses. For those predisposed to believe in UFOs and government cover-ups, Lazar's assertions offered compelling, albeit unsubstantiated, evidence that aligned with their views. This psychological aspect has contributed to the enduring division between believers and skeptics. Amidst the debates over the veracity of Lazar's claims, a broader demand for transparency and accountability from government and military institutions has emerged. Regardless of the individual stance on Lazar, his story has amplified calls for the declassification of information related to UFOs and UAPs, leading to a more open discourse on these topics in recent years. The Lazar effect underscores the importance of the scientific method in evaluating extraordinary claims. The scientific process relies on evidence, reproducibility, and peer review to validate or refute assertions. Lazar's claims, lacking in empirical evidence and subjected to limited scrutiny through these lenses, highlight the challenges faced when extraordinary narratives capture the public's imagination. Similar cases and parallel discoveries. The narrative woven by Bob Lazar is not an isolated phenomenon within the realm of ufology and alleged government secrecy. Over the years, several other individuals have come forward with claims of insider knowledge about extraterrestrial technology, secret government projects, and encounters with unidentified flying objects. This chapter explores some of these cases, drawing parallels and contrasts with Lazar's revelations, and examining their impact on the discourse surrounding UFOs and alien technology. One of the most notable figures in this context is Philip Schneider, an engineer who claimed to have worked on constructing deep underground military bases, DUMBs, that housed extraterrestrial technology and beings. Schneider alleged encounters with alien species and detailed battles between humans and aliens deep beneath the Earth's surface. While Schneider's claims lack substantial evidence and have been met with skepticism, they echo Lazar's narrative in terms of alleging deep government secrecy and the existence of alien technology. Paul Benowitz, an electronics specialist, became convinced that he was intercepting communications from alien spacecraft while monitoring military frequencies in the 1980s. His investigations led him to believe in the existence of a secret underground base near Dulce, New Mexico, where humans and aliens worked together on sinister projects. Although it was later revealed that Benowitz had been fed false information by the Air Force Office of Special Investigations to distract him from sensitive military projects, his story contributed to the lore of secret government alien collaborations and has parallels with Lazar's Area 51 claims. In a different vein, Gary McKinnon, a British hacker, broke into U.S. military and NASA computers in 2001, seeking evidence of UFOs and free energy technology. McKinnon claimed to have found evidence of a secret space program called Solar Warden, which allegedly involved a fleet of spaceships protecting Earth from extraterrestrial threats. McKinnon's case is distinct in that it involved digital evidence, though no conclusive proof of his claims was ever presented. His actions highlight the lengths to which individuals will go to uncover supposed secrets about UFOs and alien technology. Edgar Mitchell, an Apollo 14 astronaut and the sixth man to walk on the moon, publicly expressed his belief in the existence of extraterrestrial life and the cover-up of UFO encounters by governments worldwide. Mitchell's status as a respected astronaut lent a unique credibility to his claims, though he did not present direct evidence of his assertions. His willingness to speak openly about UFOs and alien life forms a compelling parallel to Lazar's narrative, suggesting that individuals from diverse backgrounds and with varying levels of access to classified information have reached similar conclusions about extraterrestrial phenomena. The cumulative effect of these and other whistleblowers and alleged leaks within the UFO community has been a persistent questioning of official narratives regarding unidentified flying objects and extraterrestrial life. Like Lazar, many of these individuals have faced scrutiny, disbelief, and challenges in substantiating their claims. Yet their stories contribute to a broader narrative that suggests a complex relationship between government secrecy, advanced technology, and potential extraterrestrial interactions. The challenge in evaluating the claims of Lazar and other whistleblowers lies in the inherent difficulty of verifying stories that, by their nature, involve highly classified or non-public information. The scientific community's demand for empirical evidence and reproducibility stands in contrast to the anecdotal and often unverifiable nature of these accounts. As such, the discourse around UFOs and alien technology remains a contentious field, where belief and skepticism coexist in a delicate balance.